Okay, this is just a quick demonstration. I did another video on this, but this is a little clearer. You can actually see it in action. I have the same circuit. I haven't changed it. It's exactly the same as it was before. I've got 9 volts applied to it. We have an open circuit. The only difference is I've got my ground now connected directly to my lead. Put that in there so it's not bouncing about. There we go. So I'm going to put this on my circuit, just exactly the same as I did before. This is a different meter, but it says 1, and that means overload this one. So with non-auto ranging meters, you've got to work your way through the different ranges till you get a reading that actually makes some sense. So we started off with the lowest, and I'm going to climb up, and I can still get a 1, climb up again, get a 1, climb up again, and I get a reading of 28.9. Okay, that when I look at this, the top end of that is 200 milliamps, so that's 28.9 milliamps. Let's go to the 10 amp setting, and I get 0.6. Now, in this particular meter, oh, I know what the problem is. I'm supposed to move this because that's the 10 amp. Let's take a look. I'll move that to 10 amps. I've not changed anything on my circuit. It's exactly the same before. Let's see what happens now when I try doing that. And it tells me I got 0.08, which is not the correct reading. If I move it back down to our 200 milliamp, it's not going to give me the right reading because this is now in the wrong location. So when you're working with older meters, and it's entirely possible that you work for a company, they've got a company van, they've got a company meter that they've used forever in the day, and they say just use the one that you got in the van. You have to learn the meter. It doesn't hurt to spend 5 minutes, look the model up on your phone, get the manual online, figure out what it does, and then try it out. Check to see that it actually does what it's supposed to do. And if it doesn't, on these older ones, you have to set the range. Make sure you read not only the function screen, the manual, RTFD, read the function dial. All of those, and of course, make sure your leads are in the right position. All of those will make your job easier and be a safer day, and you get to go home and play. Okay. of the wires. Interesting. Would not have anticipated that. But your job will be to measure each voltage drop as it occurs. You'll first measure the resistance and continue to add the resistance up. So you'll measure these two as a circuit, those two as a circuit, those three as a circuit, those four as a circuit. Once you finish that, you're going to do the voltage tests. So you're going to put your meter onto volts. You're going to apply some power to the circuit. In this case, 9 volts. I have 9 volts, that's good. And you're going to start with each resistor. Again, put the most negative part of the circuit on the black lead, the most positive on the red lead. And, oh, I'm reading AC, silly rabbit. Look for the dig down the gurney. Okay, good. And I have a little less than a volt drop there. Go to the next one. And a little more than a volt there. And we're going to do that for each of them. You're going to measure the voltage drop across each. And then you're going to add them all up, and then you're going to measure the voltage drop from the beginning of the circuit to the end of the circuit. And you should find there's absolutely no spare voltage, that every volt is accounted for from the beginning of our circuit through to the end of our circuit. Once that's complete, you're then going to take the voltage readings at different spots, and you're going to then put the circuit using the meter to measure the current. I'm going to try this other meter for demonstration purposes because this meter will not read DC amps. It is designed and built to read AC only, not DC. So that being the case, put a trusty meter, put it on amperes, and we're going to put it at 200 milliamps. And I'm going to use my clamp-on leads. So I know that this point is the same as this point, so I can connect that there. I'm going to turn the power off for a second. And what we're going to do is we have to open up the circuit so that each one, at some point here, we have to open up the circuit. So I'm going to open it up here. I'm going to take the last resistor and I'm going to swing it off to the side. So it's no longer a part of the circuit. And the only way to complete the circuit is to go through the meter. So I'm going to put my negative here with the power bus, and I'm going to put the positive on the negative side of this resistor. So now the current is going to come from our power supply. It's going to go into our bus, out of our bus to our first resistor, back into the back plane, through the loop, into the resistor, into the back plane, out of the loop, into the back plane, out to the resistor, etc. until I get to this resistor, because I've got the last loop there. Now it's going to go through the meter and come back out of the meter to complete the circuit. So I'm going to turn that on. And I'm reading about 28.4, but notice I'm on 200 milliamps, so that's 28.4 milliamps. Okay, so I know that. I'm going to turn my power supply off for a second. I'm going to reestablish this back to where from whence it came, and I'm going to open up another loop. Now I'm going to go from this point and I'm going to take this, I've got to complete the circuit. That's my most positive part of my circuit. That's the most positive part of my circuit. I'm going to connect that to the most negative part of my circuit, which is the other side of that resistor. So this is coming out, and I'm going to put that in here. So now the power is going to go around here through this, out through this loop, into the meter, come back from the meter, into the resistor, back to our bus plane. And let's just see what happens. I turn my power supply on, and I get a amperage reading. And you're going to verify that on all the different resistors. Each of these loops, you're going to replace it by inserting your meter into it to get the current. And that's pretty much the lab. So you'll be doing voltage readings, you'll be doing current readings, and you'll be verifying a series circuit.